So how do electrons organize themselves into electron shells? Well, to understand that, we need to use one of the most powerful tools in chemistry, the periodic table. And the periodic table explains how things are ordered, how things react, how things will behave. And since electrons do all the work, the periodic table is essentially a representation of electrons. So let's think of building an atom like we would a house. And we're going to zoom in and start the building of our atom from the inside out. At the nucleus of our atom, we're going to have protons and neutrons. So we're going to have some atoms or subatomic particles, protons, some neutrons inside an atom. And then, because of this positively charged center, we're going to start adding in electron orbitals. And these electron orbitals are not going to represent like the common image that we do when we think of electrons, where it's like some balls and then some wire string floating around the outside. There's an image of that. But in reality, what it is we have increasing orbitals of atoms adding up around that nucleus. And so if we start with the nucleus, the first shell, the first electron shell of an atom is going to be an s orbital. And then we will have, this will be referred to as the 1s orbital. And that will be the closest to the nucleus, so it'll be the most attracted to that nucleus. The next orbital will be a 2s orbital. And the third orbital is actually 3 sets of equal energy p orbitals. We're going to have one that is up and down. We're going to have one that is this way and this way. And then the third one is going to extend out of the atom in a forward-facing direction. So we can think of, if we have the center of the atom now, we have our, let's define this as a y-axis. We'll define this as the x-axis. And then through this orbital, we have a z-axis. And so that's where our p orbitals lie. Now, this is one representation of the atomic structure, but another representation of the atomic structure is by looking at the electron configuration. And there are some rules that we're going to apply when we build an electron configuration. The first things first. For an electron configuration, I'm going to denote that as a separate thing. We're going to start with our y-axis of this structure as energy. And as we go up this hill, we're going to increase in energy. And so like I said, that 1s orbital is closest to that nucleus. It is the most stable because it is negative charges very close to a positive charge. And so our first orbital, our lowest energy orbital, is going to be our 1s orbital. And then we have a 2s orbital. And then we have our 2p orbitals. Now we have 3 of them, 2p. And I'm going to put here x, y, and z. X, y, and z. And then we move up to the 3s orbital and the 3p orbital. Actually, let me erase. No, it's fine. And as we build up this orbital, we can go to the 4s and the 4p. And then once we get to the 4p, we get the 3d orbital, and on and on and on. Sorry, this is the 3d orbital. 3d is there. 3d orbital has 5 equivalent d orbitals. Now, we're not going to talk about that. But as we go up this thing, we're going to fill this up. Now, there are some rules that we use to fill up these orbitals. And we're going to go through those in the next video.